Where do you find a particular type of whale? In the specific ocean. Okay, we have a question about a whale. It's surfacing on a still specific ocean. As it surfaces, I can't really draw a whale, but we can imagine, as it breaches the surface, there will be a ripple that moves outwards, right, with time. Right, so those are wave fronts if you study physics. And the wave fronts are concentric, they're about a circle, and they expand, or the radius increases with time. Alright, and so we're given that specific equation. We're asked at what rate is the area within that wavefront, so in other words the area of the circle, increasing. So at what rate is it increasing at a certain time? Alright, so question is asking the rate of change of area. So area. We are given the radius, so we can find an expression for the area in terms of our expression for radius. So we know the area of a circle is pi times the radius squared, where in this case, radius is 0.7 times t. So pi times 0.7 t. Alright, so pi times the radius squared. And that is 0.7 squared is 0.49. And then t squared is t squared. So just conventionally we would write the coefficient, then pi, the constant, and then t squared. So that equation tells us that the area is changing at 0.49 times pi t squared. So as we increase time, the area will increase as well. Right? That makes sense because the waves had more time to move outwards. So the circle has grown in size. Okay, so we have an equation for area. The question is asking us at what rate it is increasing. So we have an equation for area. We can find the rate of change of area. So that is the derivative of A with respect to time. The rate of change of area. So looking at our equation for area, let's differentiate that with respect to time. So we're looking at t, the power is 2. We multiply that out the front. So 2 times 0.49 is 0.98. Pi is still a constant. And then we subtract 1 from the power, which would leave us 2 minus 1 gives us 1, which we don't need to write. So this is the rate of change of area with respect to time. Alright, and so rereading the question, it's asking us to find the rate of change of area for time is 20 seconds. So what we can do is substitute 20 into our rate of change of area equation to find the rate of change of area at 20 seconds. So doing that now, 0.98 pi times 20. So 0.98 times 20 gives 19.6 pi. And you could, evaluate that on your calculator, which is about 61.58 to 2 decimal places. So either answer would be valid. Cool. And the units for that, so rate of change of area, so area is units meters squared, and then a rate of change, so with respect to time, is per second, or meters squared per second. Alrighty, so just going through this question one more time. We were given the context, which is a whale breaching the surface, and we know it's circular, right? And we're given the radius. So with that, we were able to write an equation for the area, and we acknowledged we were looking for the rate of change of area, so we differentiated it to find 0.98 pi times t is the rate of change of area. And doing those two steps would be the achieved component. And then for merit, we substituted in time equals 20 seconds into that equation and found the rate of change of area at 20 seconds. See ya.